Hi, I'm Eric Campbell, Senior Network Engineer at Acadia Technology Group. All of us at Acadia would like to thank each of you for joining our webinar today. Just a couple of housekeeping items before we get started. We invite you to submit any questions you may have in the Q&A window. Notice there's also a chat window. We will not be monitoring the chat window, so please post all your questions in the Q&A window. We'll try to answer your questions during the webinar, but if we don't quite get to all of them, we will be in touch with you after the presentation to answer any remaining questions. We'll give other attendees a couple more minutes to get signed in, but while that's happening, let me give a brief introduction to Acadia for those of you that may not know us already. Acadia Technology Group is an IT solution provider focused on the New York metro region marketplace. We also have staff in the Washington, D.C., Central Texas, and Southern California areas as well. We are a Cisco Premier Partner, and we come with a diverse set of industry experience. We're in some of the world's best-known financial houses and global law firms, retail brands, and even theme parks. On one hand, we are typical in that we do data, both wired and wireless, along with voice and video solutions in data centers and campus networks. On the other hand, we are different because we don't really do compute, meaning servers or desktops, or storage. As we sometimes say, we tend to work with bits in flight and not so much with bits at rest. And we are very services focused. We know that your business is unique, so you don't just want a cookie cutter networking solution. We also know that you want to lead, not just copy what others are doing. And that though you want to lead, you certainly don't want to bleed. We provide a wide array of services around modern networking requirements. We know it's not enough anymore to just get things connected and then lay in point solutions to address particular concerns, such as security, video conferencing, or wireless. Instead, we plan and build networks holistically, with security baked in from the start. We also use a comprehensive process strategy based on industry best practices to ensure an accurate and smooth adoption of new technologies. This life cycle is described by an iterative process of continuous improvement, which provides a comprehensive solution that is fine-tuned to your actual business requirements and ready to take on the future as your business is ready to face it. At Acadia, we want you to remain in control. We want to act as a member of your staff, not just some third-party vendor or even a trusted advisor. We want to teach you what we know as we go. We're not trying to hide some secret magic sauce recipe and keep you in the dark because it's your environment and you have to live with it. So you deserve to know what's in it, how it works, and how it was built. We believe anyone can sell network gear, but at Acadia, we want to help you safely adopt a solution and make it simple to live with, both at 10 a.m. on a Tuesday and at 2 a.m. on a Saturday night. Is it possible to make a network more sophisticated, yet at the same time more simple? Sure. Think about Apple and their products. For all the complex technologies involved in making that thing in your pocket a reality, a vast majority of its users have no clue what goes into making it work. All they know is that when they touch the screen, it does magical things. But the trend toward the digital business has made network requirements much more robust. So simple is getting harder to accomplish. Think about today's networks and how trends in customer expectations, and by customers, we mean both your internal users and your business's actual clientele. Think about bring your own device, the Internet of Things, and the security landscape with end-to-end encryption in applications, the frequency and impact of new zero-day threats, and all the widely known and lots of not so widely known cyber breaches. And think about evolving network technologies such as cloud, 802.11ac Wave 2, network function virtualization, and software-defined networking, just to name a few. All these factors are adding complexity to the networking landscape, and budgets for staff, equipment, software, licenses, and management tools are just not keeping up. These are just some of the considerations of today's situation that have an impact on modern networks. Okay, hopefully by now everyone that's going to join has, and we again thank you for attending the session today. We have a lot to cover and only the hour to get through it all. So strap yourself in and let's go. Today, we'll show you what intent-based networking technology is and how you can start adopting it in your own network. Cisco's DNA Center allows you to work more efficiently, make your network more secure, and gain deeper insight into your network. We cannot overstate how different this new way of working is. In many ways, the underlying technology hasn't changed that much. It's still fundamentally routing and switching. But if anyone on the call has been around long enough to remember, similarly minimizing comments were made about the new technology that was introduced by Calpana. Remember Calpana? They took the Ethernet hub and turned it into a switch, and they ushered in a transformative change so significant that it only happens once every 20 to 30 years or so. The insight we have into our network when we transition to intent-based networking is orders of magnitude better than we're used to having. The control we have over our network moves from device by device to dealing with the network as a whole. And the degree of security in the network is completely flipped, from trying to lock applications and traffic down to instead whitelisting what we want and discarding the rest. And not just at some select points in the network, but at every entry and exit point throughout it. This allows us to do more than we could before and to be more agile to the business needs as they are and as they evolve. But I'm getting just a little bit ahead of myself. How do we get started? Well, it's always best to start with the end in mind, but it's also unusual to just get to the end without a few steps along the way. First, we need to learn how to crawl. We can do this by getting ourselves ramped up on Cisco's DNA Center, and attending today's webinar is a good starting place. DNA Center's assurance functionality can be installed easily into almost any existing network environment. And assurance provides immediate benefits. You can work with us or with your Cisco account team to do a proof of value or a customer proof of concept with DNA Center. Once you've begun to see the value of DNA Center assurance, then you can walk by taking on more of the DNA Center functionality. This too has benefits in your network without really changing anything too significantly. But deepening the insight you have into your network and providing a basis for automation will still only take you so far. At some point, you'll have to make a bit of a leap of faith to get to the next step. With some modifications to your existing network in order to get it to comply with the intent-based networking architecture, then you can run and take full advantage of DNA Center's many capabilities to perform zero-touch provisioning, automate the configuration and reconfiguration of your network, create a fully integrated wireless and wired environment, and provide group-based and even user-based security throughout your network. Like we said, it's a once-in-a-generation change. Today, we're going to try and answer a few simple but key questions for you. We'll also show you DNA Center in action and how the assurance functionality can be useful to you on day one. All right, so first off, what is intent-based networking? As Cisco website says, an intent-based network bridges the gap between business and IT. It captures business intent and continuously aligns the end-to-end network with that intent. That second sentence bears repeating. An intent-based network captures business intent and continuously aligns the end-to-end network with that intent. But that begs the question, what is intent? To try and answer that, let's look at an example. I want to do a hike in Acadia National Park. Of course, this is a bit of an off-topic and trivial example, but let's follow it through for the sake of illustration. This is an expression of intent. It speaks to the outcome you wish to see happen. It's simple and direct, and it doesn't try to dictate all the details. It merely expresses what you want. Now, let's think a little bit about what we have to do to make this happen, to execute on the intent. To start off, there's some planning, and then some preparation, and then a transition occurs, and finally the intent is realized. There are a few important points I'd like to make about this example. First, there's an ordered list of steps that one has to undertake in order to execute on the intent. Second, different skills are involved in the various steps. Planning is a very different skill than driving, for example. Third, skills may reside with different people. For example, if you're a tweenager going with your family, you may be able to help with the planning and the preparation, but you're not going to do the driving. This is simply a skill you don't have, but that's okay. Mom and dad have that skill set. But if you're this teenager and you intended to go solo, then you'd kind of be out of luck, right? Or you'd at least have a pretty significant problem you'd need to figure out how to overcome. But now picture this teenager living in a family that has a self-driving car. If the system can do the work for you, then you don't need that skill, but you can still execute on the intent. That last point is actually a significant one in terms of intent-based networking. If the system is doing the work, then it effectively enhances your overall skill set. Write that down. There will be a test later. My tease. All right, so let's look at another example, one that's a little more germane to IT. I want to ensure that the only folks that are able to see the payroll database work in accounting. Again, just as with the previous example, intent is expressed directly and without regard to how to accomplish it. Also, as before, there's an ordered list of steps. Different skills are required for the various steps, and the skills may reside with different people. Like so many things in IT, it's a team effort to execute on intent. But some additional points about this example. Typically, today, identifying the payroll database in the accounting department in a network is IP-based. It may include TCP ports, of course, but the primary identification is done through IP addresses. Those IP addresses are essentially tied to the location in the network topology of the things that they're associated with. The creation of policy is somewhat device dependent. The syntax for iOS-based switches, where the accounting department likely is attached, is a little different than for Nexus switches, where the payroll database probably lives. Both of these are different than in any of the firewalls that may exist between the two. Determining where the policy needs to be applied may be a very complex task. Is it better to position policy right in front of the payroll database or at the entrance and exit to the data center? How does the inclusion of this new policy integrate with existing policies? All of these steps are done manually in most environments and are therefore potentially quite time-consuming, prone to human error, and subject to other problematic factors. Now, I intentionally left something off this list. Can anyone figure out what it is? Now, I realize you can't really respond to that question, but I'll give you a moment to ponder it. It's crucial to operationalize and provide a life cycle for an intent. What if the definition of the payroll database changes? Say the application is upgraded and new TCP ports become part of the mix. What if the accounting department changes? Say they move to a new building, or more simply, what happens when the membership of the group changes? What if something else changes somewhere in the network? New firewalls, a new WAN provider with a new entry point into the data center. Maybe you move payroll to the cloud. What if the accounting department all gets new laptops and moves off the wired network into the wireless domain? Then how do you track their IPs? All of this essentially creates a requirement that a feedback loop must exist, a way to consistently and in an ongoing manner ensure that as the network changes and the things attached to it change, that the policy remains valid. And that directly speaks to that second sentence above that I repeated before. It continuously aligns the end-to-end network with the intent. Okay, hopefully now you have a little better understanding of what intent is. It's what you want done without regard to how to get it done. And hopefully you also see the importance of that feedback loop, the continuous monitoring of the network to make sure it complies with the intent. Now let's look at how intent fits into an intent-based network. Intent may come from a variety of sources: service level agreements, compliance requirements, operations procedures, or new business initiatives, just for example. To actually implement intent in a system like DNA Center, the first thing that has to happen is that you translate intent into policy and check its integrity. The validation of policy means making sure the policy captures the intent, and it means understanding how the policy affects the network as a whole as it already exists. Then we have to activate the policy by pushing it to all the appropriate infrastructure devices. In the past, these have all been manual processes, and therefore they're prone to errors and time-consuming. But wait, there's more. In an intent-based network, the whole infrastructure becomes a sensor, and it's capable of providing telemetry data back to the system controller. Now, I'll come back to telemetry a little bit later. But we can see that through assurance, the system can continuously check that the expressed intent is honored by the network at any point in time. Context derived from telemetry data is used to check the alignment of operation with intent, and the assurance function maintains a continuous validation and verification loop. Now, I'm going to take a minute to introduce some terminology and describe the things that make up an intent-based network. First, we start with an underlying infrastructure. This can be new, or more likely, it's an already existing infrastructure. In an intent-based network, we call this the underlay network. The underlay network is built entirely at layer 3. There's no spanning tree anywhere in this environment, so all the bandwidth that exists in the network is available for use. We add in new control functionality using Cisco's DNA Center, which acts as a system controller, and the Identity Services Engine, or ICE, which provides a security-based policy engine. Together, these things make up what we call a fabric. Not all the devices in the underlay network need to be added to the fabric. Some can just provide layer 3 transport within the underlay and be managed by DNA Center with features like assurance. In our live demo a few minutes from now, John Stone will give you a taste of DNA Center and the assurance functionality, as well as a brief introduction to some of the other tools and workflows within DNA Center. By adding devices to the fabric, though, you unlock the entire feature set of DNA Center and enable capabilities like SD access that encompass the full potential of intent-based networking. On top of the underlay network, you create a virtual network. This overlay network is basically a VRF, a virtual routing and forwarding instance. And, of course, you can have more than one overlay built on the same fabric. As you can see, each overlay is a distinct virtual entity, and no communication takes place between them. This is just one of the ways that security is built into the model of an intent-based network. Within the virtual network, the LISP protocol. LISP is short for Locator ID Separation Protocol. LISP is used with the end effect that an address pool, a subnet, can span devices, floors, buildings, or even campuses. Now, before you run off in a panic about suddenly needing to learn something new like Lisp, remember that point I made a few minutes ago when we were talking about what intent is? That if the system can do the work for you, then you don't need that skill, but you can still execute on the intent? See, I told you there'd be a test. This is one of the advantages to intent-based networking as implemented under DNA Center. The system understands Lisp and it knows how to implement it, so you don't have to. Not a lick. The deployment of Lisp is handled entirely by DNA Center. The same is true for VXLAN. The VXLAN protocol is used to carry the data traffic, along with some important security information, throughout the fabric. And DNA Center handles all the VXLAN configuration for you too. That important security information carried in VXLAN is called Scalable Group Tags, or SGTs. If you're familiar with ICE and Cisco's TrustSec model, you may know them as security group tags. It's the same thing, Cisco just renamed them. The net effect is that policy moves through the network with a user, no matter where they connect. So you remember that accounting department example I gave earlier? In this intent-based network, a user logs into Active Directory. AD identifies them as being in accounting. ICE learns this from AD, and policies, like the one where they're allowed to access the payroll database, are pushed into the network by ICE and DNA Center. And those policies go with them wherever they are or wherever they move in the network, along with the SGTs. Because the network is fundamentally whitelist-based and no one else is given that permission but the accounting folks, the policy deployment effectively evolves in real time as the network context changes, all automatically. And this is the primary way that security is built into the model of an intent-based network. Okay, so now you know what intent-based networking is. Now let's talk for a couple of minutes about some of the benefits of intent-based networking. In a traditional network, like most of the networks you all probably work with, there's a wide variety of device types. There are different types of switches, routers, wireless LAN controllers, various networking appliances, firewalls, and so on. Each of these comes with its own variations in capability, management techniques, and syntax. In an intent-based network, the underlying infrastructure, the underlay network, it's abstracted. So instead of having to manually deal with all these devices and all their variations one at a time, you just deal with the infrastructure holistically as a single fabric. With DNA Center, you get a single pane of glass through which you can control and monitor both the underlay and overlay networks, and you express intent to DNA Center through its design and policy workflows. You also get a large open set of APIs from which you can extract information and through which you can orchestrate changes into the network. DNA Center is expert in modern networking technologies such as Lisp, VXLAN, TrustSec, QoS, and so on. And because DNA Center bases its configurations on Cisco-validated designs and best practices developed by Cisco with all their collective years of experience and the depth of their collective knowledge, you can bring these technologies and all the benefits that come from their use to your network without having to become an expert in them yourself. Think again about your current network context. Chances are that all your network policies are manually developed, which can be quite time-consuming. Also, think about the number of changes that are made, the number of devices those changes are made on, and the number of variations of capability and syntax that exist on all those devices. When you do the math, it can add up to a whole lot of lines of configuration code that need to be put into the network. And chances also are that all those devices are manually configured. Did you know that up to 80% of configuration errors are due to human mistakes? Now think about an intent-based network. As we discussed earlier, the translation functionality of DNA Center checks the validity and integrity of the policies you build. Because the configurations are constructed within DNA Center based on validated designs and best practices, and because those configurations are pushed through automation from DNA Center to the fabric, the likelihood of error is practically eliminated, and the time to deploy is radically reduced. By being based on a whitelist model instead of an open traffic model and blacklisting, and by having independent virtual networks that can't talk to each other through the fabric, and by being rooted in TrustSec with the group-based and even user-based control that brings, an intent-based network is highly secure. In most networks today, the wireless domain is essentially separate. Sure, the wired domain is used to transport the data once it comes off the airwaves, but the administration is separate. The transition from Wi-Fi to Ethernet isn't particularly graceful when you consider things like the differences between QoS implementations in the RF world and the wired world. And in many cases, user traffic all seems to emanate from the controller, which means the traffic patterns are likely not optimized. In the fabric, though, the wired and wireless domains are much more tightly coupled. A DNA fabric allows the same policies to be applied to both domains. The transition from RF to Ethernet is improved and made more unified. And because of the interaction between VXLAN and security group tags, or scalable group tags, user traffic emanates from the APs and is routed across the fabric in a much better way. Now, a lot of these benefits that I've talked about so far are based on a fully enabled fabric. Remember crawl, walk, run? Many of these only come at the run stage, so it's going to take some time to get there. These aren't all going to happen in your network the day after you put DNA Center in. To be realistic, it could take months or potentially even a year or more before you realize some of these benefits. But don't let that deter you, because DNA Center's assurance functionality is different. Remember, in the fully realized fabric, assurance provides that feedback loop to ensure that the network is doing what you want it to. But in any network, assurance can still gather information and provide useful functionality. You can put DNA Center in your environment in one day, and then within DNA Center, you can discover an existing infrastructure in order to add the devices to the DNA Center inventory. At this point, DNA Center is capable of managing and monitoring the devices, and it's acting much like a network management tool. And quite a wide variety of Cisco devices and software versions are supported. And you can have this up and running the very next day. Take a moment and think about your network management environment. You've probably got a proliferation of network management tools. Each requires a bit of specialized knowledge to set up and use, and each provides only fragmented or incomplete visibility into your network. Most of them are probably SNMP based, so they're a bit slow to react, and each tool is independently polling the network devices, which is inefficient. The data they collect is not directly actionable. It requires correlation, which can be difficult between tools, and it's not designed for analytics. Usually the data is unstructured. All these factors lead to a host of troubleshooting woes. According to a McKinsey study of Cisco's network operations done in 2016, 43% of IT's time is spent troubleshooting, nearly half. And of that time, 4 times more of it is spent collecting information than actually analyzing the information. That means that roughly 1/10 of IT's time is spent productively doing troubleshooting, while about 1/3 of their time is essentially wasted. And what about those problems where you get a call on Tuesday about something that happened last Friday? The inability to replicate a problem often leads to problems that end up never being resolved. These things slow the whole process down and chew up everyone's valuable time. But more importantly, they diminish the end user experience and decrease satisfaction. Well, DNA Center's assurance tries to address all these issues. First, it's built based on telemetry data. Now, I said I'd come back to telemetry, so let me do that now. As I just said, traditional networks use a lot of SNMP and maybe some CLI scraping to get information from devices. SNMP is based on a pull model based on polling to get data, which is both inefficient and doesn't scale well. They also use syslog, which at least is event-driven, but the data is at best only semi-structured. Some networks also use NetFlow, which is push-based, and that's good. But NetFlow pushes are themselves timer-based. Devices typically only export aggregated data every 60 seconds. And NetFlow is only related to traffic flows in the data plane. Telemetry attempts to optimize or correct all of this. It uses a push model, so it's event-driven, and data is streamed rather than polled. It reports on the data plane, so it covers flow data, but at a higher frequency than NetFlow does. But it also includes the management, control, and device planes, so it is therefore much more comprehensive. And telemetry data is structured using the protobuf format, so it's useful for analytics and machine learning. Now, this does not mean that every conceivable bit of metadata is continuously streamed by every device throughout your network. Some telemetry data is cadence-based, meaning it's based on timers. And more importantly, what's included or excluded is controlled by policy. So, now that we have a bit of an understanding of what telemetry is about, we can see how DNA Center is able to collect telemetry data and perform analytics and machine learning on that data. DNA Center also still has access to SNMP, syslog, NetFlow, and the CLI, so the amount and variety of data available to it is significantly superior. And this leads to deeper network visibility and correlated insight into what's going on in your network. DNA Center Assurance also provides guided remediation, where the system offers suggestions on how to troubleshoot particular problems. And those suggestions are based on TAC's broad experience dealing with customers' real-world problems. And many of the steps are often actionable directly from DNA Center, meaning, for example, if they suggest doing a trace route, they also offer a button to click to actually do the trace route and get the results right on the same screen without having to leave to go fire up another tool. And because DNA Center stores all this data for at least a week, there's actually a way to rewind the clock and go look back at what was happening last Friday when you get that call on Tuesday. To put it all together, you can solve more problems and spend less time solving them with DNA Assurance. It's all pretty cool, and I hope you're kind of pumped to check it out, because now it's time for me to pass the ball to John Stone so he can show you some of the things I've been going on and about. So, without further ado, here is John Stone. Hang on. There we go.
Okay, thanks, Eric. A very helpful introduction to intent-based networking and good introduction to DNA Center's Assurance application. What I want to do now is to first share my screen. we can see what's up. And then I want to take a little bit of time to go through DNA Center itself, and so we can look and see where we will translate our business intent into policies, look at how policies are defined, as well as how our network design can be defined. We'll look at how those policies are activated or applied to the network devices, and then spend some time looking specifically at assurance and some of the real information that we've collected in our own network. So let's take a look at assurance. And when you first log in, you get a screen that looks like this that tells us immediately a little bit about our network overall. We've got an overall health score, how healthy is the network based on all of the information DNA Center has collected. 78% in our case. That's not perfect. It's not bad. We'll look at in just a minute at what makes up that score. We notice our wireless clients seem to be doing just fine, and our wired clients are also doing fine. If you look at the wireless clients, though, and this is for a 24-hour period, you notice that there's been some ups and downs, and we'll look at those in just a little bit more detail, understand what might be going on there. We also get a quick summary of our network overall, the number of sites in the network, the number of devices, and so on. And keep in mind, this is a lab network, so it's not huge. The next section here on the home page is the various workflows, and notice that these workflows are also available at the top of the page. So here's where we can describe our design through DNA Center, describe policies, provision the network devices with those policies, get access to assurance, and then the platform section is where we can begin to configure programmatic access to DNA Center for those who want to write their own applications that run on top of DNA Center. There are a number of tools here at the bottom that are used by DNA Center, things like network discovery, inventory to keep track of the devices, and so on. And we'll look at a number of those. So, again, we've got our business intent that needs to be described and defined. The first place we're going to do that is in the design section of DNA Center. Networks exist in real places, and so DNA Center gives us the ability to identify those places. Our lab network, for example, exists in North America. We've got a number of locations in half a dozen states. So we can work our way down the hierarchy here. As it turns out, our data center is in Danbury, Connecticut. And the data center, like most buildings, has floors. Our equipment is on the ground floor, so that's the one that's defined. You're not really limited to describing your network geographically in this way, but it makes sense for most people's networks. So this is all nice, but why would you do this? One important reason is that most of the time in most networks, we divide our address space among the various locations. We don't try and use the same address space everywhere. That would not be a very efficient network. So sure, globally, we've got a number of address pools, and these address pools basically are subnets, but they are the address space that will be used by network devices throughout our network. But within each of our network areas, within our network hierarchy, then we can specify what IP subnets are used, and notice that some of our settings are going to be inherited from the global pool or from the global network definition. Some are local. And here in our data center, out of the 8 IP address pools that were defined, we've got 4 that are actually in use. And same would be true, or could be true in each of our other locations. So network hierarchy, where we can apply information like IP address pools. We might also have different credentials in each region of our network. You may have credentials, CLI credentials, how you log into a device, SNMP, and so on. These all may be defined globally, and that's fine, but in some people's networks, it may be that there's a relatively self-sufficient office or location, and so the credential information can be unique to that particular location. Also, in our network settings area is a list of the software that's running on the network devices, and from here we can create tasks to update devices with appropriate software. There's of course other ways to do that, but this gives you one location to go to make sure that the right software is running on each of your devices. Notice that the devices are not necessarily called out individually here, but they're categorized. So we've got our network, basic network settings, address pools, credentials, and so on. The next step is to create our network policies. And those policies consist of things like, well, who can talk to who? Who's allowed to access our database servers, our payroll database servers, or who's allowed to access our PCI servers for processing customer payment card information. And to support that, then we have we have groups defined. DNA Center comes with a number of rather generic groups, but we can also define our own, should define our own. And those groups then are used in access control policies. And we've defined one here that describes how employees can interact with production servers. In this case, this is a rather broad rule. Typically, you'd be much more restrictive. But this is just one example that says Acadia employees are allowed to communicate with production servers. And likewise, DNA Center automatically created the reverse rule because they told it to, actually. Production servers are also allowed access to Acadia employees. In an attempt to make this easier to implement over time, DNA Center also has IP access control policies, basically just like normal iOS access lists. And we have our network groups, our subnets, and so on, and then the access control policies themselves. And these will all be applied in the provisioning section, and we'll see where that happens. So there really are two levels, and Eric hinted at this in his discussion. There's really two levels of access control within an intent-based network, within our fabric. The first, as I say, is the degree to which source groups, scalable groups, are able to communicate with each other, but we also have virtual networks that describe how groups, if you will, of groups are able to communicate. And so we have to define our virtual networks. These top two come by default as part of DNA Center, but then we define our own virtual networks. So here's a virtual network that includes Acadia employees and production servers. And within the fabric, no other groups are able to communicate with either of those within this virtual network. These two groups communicate with each other based on the scalable group rules that we've created, but that's the extent of it. Or we can have another virtual network with that allows PCI terminals, PCI devices to communicate with PCI servers, and that's it within the fabric. Now, outside the fabric, there's a way to control, to allow somewhat limited access that you might need for management purposes, for example. So here's our, in this area, we've defined our policies, virtual networks that include specific groups, and then rules for how those groups communicate with each other. To pull all this together, then, we need to go to the provision section. And the provision section is where we apply the policies in our network design to devices. Oh wait, devices. Where did they come in? We haven't really talked about devices yet. And that's where we use some of our tools. So we've got a discovery tool, and we go that we can use to discover our network. And as Eric hinted or mentioned, this discovery tool works regardless of whether or not you're going to fully implement an intent-based network, build your fabric, specify virtual networks and scalable groups and so on, or whether you're just going to use use DNA Center to get started with assurance. You'll use discovery. And so pick a discovery that we've run in the past. We found 8 devices. A couple of them weren't appropriate for the network for various reasons, and so they're left off, but successfully discovered 6 devices. And in the details section here, we see the CDP information that was used to launch the discovery, the IP address range that we started with, and credential sets, and so on. Here's where we start. It may be, if you might recall that we have 12 devices in our network, not just 6, and it may be that the discovery doesn't work for all devices, at least not the first time. So there's an inventory tool that we can use, partly to keep track of what is in our network, as well as make some limited changes, but also we can add devices to our inventory manually. Clearly, you don't want to do that for more than a few devices. If you've got 2,000 switches in your network, you'll want to make sure that discovery is working well for you. So, going back and looking at provisioning. Again, device list. Provisioning really is the step of building our network fabric. And there's a default fabric that comes as part of DNA Center. Normally you'll want to use a fabric of your own definition, and so we've defined one, our Acadia data center, which oddly enough lives at the data center level in our hierarchy. And the devices that are highlighted in blue are the devices that are included in our fabric, And notice that we have the fabric roles identified in the little circle. This is just an edge node. The top switch is both an edge node as well as control plane and border node. And once the device has been added to the fabric, we can configure switch ports to actually implement all the policies and design that we've been talking about. To do that, we select a virtual network. We select an address pool. And I've already done these steps. I'm not going to redo them. And then from that point, we select the switch that the policy should be applied to, and then the switch ports. And if you'll notice, a number of these switch ports have already had policies applied to them. But actually deploying the policies is as simple as selecting the switch ports. If all the ports on the switch happen to be, are going to be provisioned with the same policy, then just click the Select All button. And we assign the policies, identify the types of devices. This is just normal user devices, computers, laptops, phone, whatever. Select an address pool. This is the address pool I want to use for this particular set of ports, and make other selections. We're not doing port-based authentication in this case, and say update and so on. This takes just a few seconds. I don't want to take time to wait for, but you can see where we have applied these policies on a number of ports on this switch already. So once that process is complete, then the ports that have had these policies applied become part of the fabric. They become part of the overlay network. Switch ports that are not, to which the policies have not been applied, remain as part of the underlay network. So, simple, right? All we have to do is think about our business intent, turn that into policy descriptions, create the policies, identify the groups, identify the IP address pools, create those. This is what, a couple hours work? We can do this over a weekend, right? No? If you get the idea, there's a lot here. That's the right idea. It does take time, and you're not, unless you're in the fortunate position, I guess it would be fortunate, of building a brand new network. You're likely not going to be in a position to do this right from the beginning. Now, having said that, Cisco has a couple hundred customers, or a little over a couple hundred customers that are already using this intent-based networking technology in production at some level in their networks. So the technology's there, it's real, it works, but it does take time to get there. We've been working with some customers to get there, and then the process does take time. But that's not to say the DNA Center is only useful on an all-or-nothing basis. As Eric has said, the assurance application provides a great deal of value. First, as I showed, you can use it to discover your existing network, find the devices. Any reasonably recent device is one that can be managed to some degree by assurance. We even have an end of support 3750 in our network, and assurance is able to communicate at some level with that. It doesn't work perfectly, but we are collecting information from that device. And newer devices are pretty much all supported by assurance, even if they might not be supported for all of the intent-based networking functions. So let's look a little bit at assurance itself. And on this first page, the home page, if you will, for assurance, we get all of the intelligence that assurance is applied to the data that it's collecting, that bubbles up, is correlated, and gives us, at first, a very high-level look at what's going on in our network. So if we notice our clients actually look like they're in pretty good shape, though again, wireless clients over the last 24 hours have had their ups and downs a little bit. We've also got a problem with some of our access points, or one or more of our access points. And notice that this, by default, deals with the last 24 hours. We can select other time periods up to a total of 7 days. There's also a section here at the bottom for problems that have been identified in the network, and we're fortunate over the last 24 hours there weren't any. But we do need to look a little farther back. So let's go back and look at the last 7 days, and oh, well, we have had a problem of really a global nature. EIGRP. Well, that suggests there might be a routing problem somewhere. There perhaps was a routing problem. Apparently there isn't now because it doesn't show up in the last 24 hours, but there had been a routing problem. So think about how you troubleshoot problems like that. What would often happen is that somebody suddenly finds they can't get to some service that is in the network, a web server or a database server or what have you. They can't log in. What do? They call a help desk. Help desk is connected somewhere else in the network, and they go and look and say, well, no, the Active Directory server is there. It's just fine. I logged in without a problem. So I can't really do anything about that. Let me pass that off to the operations group, and the operations group will go and look and explore, and eventually they'll figure out, oh wait, if I look farther along in the network, I find that I'm missing some routing information. Well, I wonder why that is. And they keep looking and discover, oh wait, I'm not hearing from my buddy across the way. I've got something wrong, and in fact, if I look at my log, I see that I've got a problem that EIGRP was reporting. It lost track of its neighbor. All of that processing, all of that troubleshooting can take some time, an hour, a couple hours, depending on how, either how efficient or really just sometimes I found something just by good luck, you happen to land on the cause right away, but not often. But here, right at the top level of DNA assurance, I see that there was a problem to do with routing in some way. And furthermore, I see exactly the network devices that were involved, the addresses of the devices that were involved. So without giving it a whole lot of thought, I know right away where to go look. And if I select the message, then I get some repetition of what went on. And I get a number of suggested actions to find out, well, what's really happening here. And as I said, the problem existed a couple days ago. It's since been fixed, but I can, in fact, ping my neighbor and say, hey, can I at least get to the neighbor? And, well, yeah, I can now. And as Eric mentioned, notice that I haven't had to leave DNA assurance in order to do this ping. Well, I can check, okay, so I've got physical connectivity, but do the EIGRP processes on the two routers involved actually know about each other? And if I can look and say, well, yeah, sure enough they do, then the problem's been resolved. It's working fine. And there's some other steps that can be followed to make sure that everything is working correctly. And, well, you know, at the bottom, if all else fails, call TAC. And that shows up for some of the troubleshooting. But again, that's taken me all of a couple minutes, and I've been able to identify where in the network the problem existed or occurred and what to do about it. Another quick example of assurance, favorite of mine, is looking at the what's going on with one or more of our access points. And again, I want to go back a ways to make sure I capture the whole series of events. And notice, yeah, I've got a complaint about access points, and it tells me right here at the top, I've got a problem with noise. Well, that suggests an RF problem. And so I can scroll down, I can select the access point, and I can scroll down here and find the access point. And since I know that the complaint has to do with noise, I can focus on RF information right away. And so here's the access point, looking at RF information. Sure enough, both the channel utilization, interference, and noise for the 2.4 gigahertz radio are all unusually high. As it turns out, this particular access point is in the middle of downtown Manhattan, so or midtown Manhattan, I should say. So yeah, there's no real surprise that there's a lot of noise, a lot of interference. The right away, I know, and I know because I do spend a fair amount of time with wireless networks, that in the past it's been very hard to identify this information. Sometimes take specialized tools or extra time with the available management tools, but right away I've been able to identify what's going on. The solution's obvious, is to encourage the user to use the 5 gigahertz channel where noise, interference, utilization are all very low and have been low. So this is just a taste of some of the things that you can do with DNA assurance. What do we do next? Well, Cisco has a large number of articles and a lot of information on their website that'll give us that gives more information about DNA Center as a whole, about assurance, about any aspect of intent-based networking. That's certainly a good place to go look. On my next slide, I have a URL that you can use to get started. Cisco Live has a number of sessions that describe all of this technology in much more detail. Presentations that are well worthwhile. If you've been to Cisco Live, if you're going to go to Cisco Live, it's highly recommended. You already have an account and can get access, but even if you've not been, you can sign up for an account and get access to their library of presentations. And there's a number of other e-learning and training opportunities available. Beyond that, though, call us, and be glad to work in more detail with you with more demos, more specific demos. We can work with you for a specific proof of value, or help you set up a proof of concept in your network to see how DNA Center is going to help you. We also have, we can make available under specific conditions, we can make available some time in our lab and provide some consulting time. And by all means, keep track of your Cisco account manager. DNA Center is at the beginning, intent-based networking is at the beginning of its life cycle. It's real, it's here, but there's lots more to come, and Cisco can help you keep track. I'd like to thank you all for joining this presentation. You can get more information from us or a copy of the slides as part of this by emailing info@acadiatech.com.
Thanks, everyone, for joining us today.